All right, we are live. We are jumping right into it. Happy Friday, Darko.
Wait, happy Friday. Wait, I need to tweet this out. Where are we live? Are we live on YouTube?
We are
I would
on
imagine.
YouTube. We are on LinkedIn. We are on
LinkedIn.
X.
On
We are on
X.
Twitch.
Let me live with. Who are you, Stephen? Stephen JB. Steve JB. I always have a hard time finding your Twitter account on Twitter. So talking about Lisp and Lisp and generative AI. Fire.
Well, and
fire emoji.
We are in the CloudFix. Which one did I set it on? I have so many in my StreamYard.
It is CloudFix. It is CloudFix.
We're on the CloudFix.
No, AWS made it easy live stream. Okay.
AWS made easy on Twitch for AWS made easy. What are we on X? X, we're on CloudFix.
Okay.
Got to come up with the. There we go. Let me give you. Okay. Put it in the chat for you.
Okay. I posted it in.
There we go.
We are golden.
Please join. Hello, everybody.
Hello. There we go. Hello.
Now I've muted. I'm watching the streams, but put them on mute so that I don't hear ourselves with a delay.
Okay, good. So today we're talking about this thing. What? Lisp and BedRock and generative AI. So
yes,
I guess what are we gonna do today, Stephen?
Okay, well, here we go. Now for some context, Lisp is interesting. It is a old language, right? Coming from the 50s and 60s, coming out of the MIT AI research labs. And so I thought it'd be kind of fun to marry these things together. There we go. Look at that Lisp syntax.
Lisp,
all caps.
In my personal opinion, has one of the worst syntax in the world, but that's just me. Fight me on it. But it is a very old language. Like this book itself, from Patrick Henry Winston and Berthold Klaus Paul Horn, comes from 1981. And yeah, it's like, of course, you have Stallman here as one of the acknowledgments. Of course, you have to have Richard Stallman, RMS. But yeah, so tell me about Lisp. Why Lisp? What's Lisp and all that fun stuff?
Well, I guess the interesting part about Lisp is that it kind of can represent every paradigm.
Okay.
So let's see. There are, you can do functional programming with Lisp. You can there's a thing called CLOS, which is the Common Lisp Object System, where you can do object-oriented programming. I've heard Lisp described as the Maxwell equations of programming, meaning like it really boils down the fundamental essentials, the fundamental axiom, because a lot of other programming languages have higher level constructs on top of them.
Okay.
Whereas Lisp, they describe like this is the simplest possible way to represent I don't know if that's just, it's a very simple way of like representing the fundamentals of programming, at least as we know it.
Okay.
Now,
does it have this? So again, never written a single line of Lisp. Does Lisp have like variables? I'm gonna say yes. Right.
Yes.
It
has got variables. Yeah, functions.
Do we have objects?
Yes.
Okay.
Yes. There's a thing called def struct, which can make
so it's
an
like
object.
Struct. Okay.
Yeah, exactly.
Okay, that's cool.
Let's see. The cool thing about Lisp is that when they say data, your data and your functions, they all kind of live in the same place. It was one of the first languages where you can pass a function around as an argument. So in some languages you can't do that.
Right, exactly.
So that's one of the neat things. And to be honest, I haven't done very much production Lisp. I've done a lot of kind of exercises in Lisp, but I haven't done exactly. I've customized Emacs quite a bit, but that's to be honest, a lot of cargo culted snippets from the Emacs subreddit and from Stack Overflow to get things to work. Now I use ChatGPT to customize my Emacs Lisp.
which is the way to go, right?
It makes it a lot easier. But now that we've got that, what I really wanted to try is, can we connect the AI circle
Okay.
and talk to Bedrock using Common Lisp?
Okay.
So
Okay.
that is the thought for today. And so
Okay.
luckily, Bedrock has a REST API. Uh, so what we need to figure out is, well, a how to call a REST API from Common Lisp, and
Okay.
then I guess is A.1 is how to sign a request in
Okay.
such a way that Amazon will accept it.
Okay.
And it's actually kind of neat. For those who haven't called an Amazon API directly, there's actually an AWS signature method called AWS Sig4.
Okay.
So we have to get that to work in Lisp. You can't just pass your key access keys as headers. That for I guess for reasons of security, that wouldn't be a good idea. So we have to do our
Okay.
access. We have to generate the signature to authenticate. Once we do that successfully, we're going to get back a Lisp. Well, we're going to get back the response, and then let's figure out how to parse that um, into JSON, or parse that into a Lisp object that we're going to get back a JSON response to parse that, and then hopefully we can do something interesting with it.
Okay.
So I think that would be
Okay.
a good goal for today. So, like I said, I've done programming exercises in Lisp, write this recursive function, that kind of stuff,
Okay.
fun things, but nothing that has to deal with the outside world. So this is going to be a learning experience for the both of us. Luckily, we have AI at our fingertips, so we can
Okay.
hopefully use a bit of AI to help us connect to Bedrock, and then we can use more AI. This is almost like a bootstrapping.
Okay. Okay. So how about this? How about this as an intro? As an intro to all of this, you teach me how to write a simple program in Lisp. How to write "Hello World" in Lisp.
Okay, well,
Would you be able to do that?
let's give it a shot.
Let's give it
Okay,
a shot. Okay. So
so
I'm gonna share my screen, and feel free to wait a second. Don't put it up yet. Give me a second. I need to close a couple of things. Okay. Feel free to pop that up on the screen.
okay,
This is my Linux terminal. There's nothing you
let's
don't see here. Really. Um,
all right. Let's
hello,
put this
better.
here.
Hello, Lisp. Right. And
Wow.
I want to do some Lisp, right? And I'm gonna do probably some blasphemy because I'm gonna write some Lisp in Vim. So,
Oh my
um,
goodness.
so what is the thing I need for a Lisp? I would imagine. There's a bunch of which is the implementation? Is this SBCL? This one you're
SBCL,
okay.
which
So
stands for Steel Bank Common Lisp. And I don't
okay,
know if there is a Steel Bank anymore.
okay,
Steel Bank.
okay, okay. So I've installed SBCL. Look at that. Look at that. Oh, but no. How does one
Oh, I see. Steel Bank. It's referring to Carnegie Mellon University.
okay.
And Andrew Carnegie made his fortune in the steel industry. Andrew Mellon was a successful banker. So Steel Bank for Carnegie Mellon.
Oh, okay, okay, okay. Uh
Oh,
SB
it looks like you're
EXT.
in it.
How do I exit?
All right. Let me put this up as a banner. So everything in Lisp is in parentheses. We're going to want to do this. Oh, oops. That.
Quit. Okay. Quit. There we go. Okay, beautiful. Okay, awesome.
All right.
Then let's do the following. I'm gonna go to where should I go to? I'm gonna go to workspace, projects. Let's create a thing. mkdir learn Lisp. Oops.
So
To
now
learn.
later I'm going to have to make a learn Rustlang directory. We're going to have to do the opposite because
Yes.
I think Rust might be slightly more applicable to today's programming
Of
environment.
course.
But
Okay, so let's I'm gonna do vim hello.lisp. I would imagine. I don't have a oops, wait a second. JPG. I need to decrypt something. Once again, hello Lisp. Okay,
All right. Ready?
ready. Oh God, is that it? Print. Hello. Since I'm from Serbia, I'm going to say Zdravo Svete, which is the same thing. Save, and I can do what is it? Is it Alt? No. Okay, so I do this, and then I do. Do I have to run SBLC, or how do I run this now? So
That's
what's the deal?
That is a great question. Let's
Okay.
let's see. How do I compile an SBCL Lisp program? I believe you're going to want to do SBCL dash dash. Okay. Let's try this. SBCL dash dash load.
Let me just get out of here and then go to Lisp. Hello world. CD hello world. Hello Lisp. Okay. So you said SBCL dash
load hello.lisp.
Look at that, it's running. Yay!
There we go. Now we could use it to compile to a binary. There's a named function called save Lisp and die.
Okay. So is it here? Just save.
Yeah, you should be able to do here. Let me send it. Let me put it up on the screen.
Okay.
I think you'd want to be able to do the following.
Now, while Stephen is doing that, I just want to say that he has a lot of his Emacs who do this for him, right? I'm doing this, as you see, on a brand new system without this thing. So, okay, wow, that is a command. SBEXT, save Lisp and die. Yes, please. Give it a program name. We're going to call it hello Zdravo, actually. Top level is there a space, I guess? Space main executable T. Okay. This feels like it's not gonna work.
Let's see.
It didn't work.
Did
it? Did it work? Okay, no. Debugger. No, it did work. Is it? No. Oh, there's no main function, right? So
okay. So you have to do, let's see.
So I guess instead of the main stuff, instead of the main, we just compile it just like that.
Let's see. Okay. Now again, I have very little production experience with
That's okay.
Lisp. But let's see.
We're learning. We're learning.
SBCL compile Lisp. I wonder if you can do. If you do SBCL dash dash script on the file name, let's see what happens to that. So this one,
So SBCL
dash script.
Hello Lisp. It runs it. So that's positive.
But we didn't compile it.
Yes. Okay. Let's. You know what? Let me be slightly crazy and do how to have SBCL compile a Lisp file into a binary.
It's that save Lisp and die.
It will give you that. So okay, yes, it does the same thing. Does anyone find my program? Okay, interesting. Yeah, so the top level is argument in the top level function specifies the entry point of your program. Make sure to replace the program with an actual of the function you want to use. So technically, we would need a function in this case for this to work, right? Like this feels like just doing print makes no sense, right? Because there's no entry point. I mean, the entry point is nothing.
Mhm.
I don't know if we can say like, can the entry point be nothing, as I have no main function. Oh, not that. I can do this. Oh, come on. Oh my god. Key. It doesn't work. This thing doesn't really work over. There we go. Okay, that works. Okay. Entry point for Lisp. I'll typically find the top level argument. However, if you don't have the thing, you can use a script instead of load to compile a Lisp into binary without specifying the. So script my program Lisp. You can do that. Okay, so we can do that. Okay, I see how this works. So 1 second. Chat GPT. I'm gonna go copy this thing. That I'm gonna go here. I'm gonna.
Oh, you can define a main function. I see.
You can define a main function, right? Of course. So in this case, I'm gonna because there is no what is it called? There's no main function, so we're gonna just say like this. Let's say, oops.
And then I think I've found something if you haven't.
Okay. We're gonna call it my program. That is okay. But I'm gonna do here instead of this. I'm gonna say is the Lisp. It failed. Zdravo.lisp. Oh, it's hello.lisp. Oops, sorry. Okay. All right. Now, there's no still. It doesn't output. Like I feel like it should have outputted save Lisp and die and as my program, right? And it doesn't do it. Interesting. Does it save it? Maybe saves it somewhere else, but you can see it runs sbcl script hello and then eval. I guess it should run this command: save Lisp and die. My program executable T.
Yeah. That. Now let's see. Or do you need to use it with the -- script command? This is more involved than I thought.
It is. It is. Look at that. Well, there
Okay.
must be a reason why people don't use Lisp as much.
Apparently, there's a thing called the ASDF3,
Yes, that's
which
a different
is
compiler.
for binary deployment. And
Okay.
let's see, that is a way to do it. There's also a nice thing called Roswell.
Roswell, it seems to have a full stack environment, at least what I see.
I see. It's a bit heavy for this.
I don't know. It says it's a full stack environment for common Lisp development, has many features. So I can try that. I mean, I can get out of here and say this, yay, Roswell. Let's see if we have the Roswell package. We do. I have no idea how this works. If I do Roswell, what is that? Roswell. I don't even know how to use it. So I'm sure there is a thing. Let me see if I can find the Roswell.github.io. It's just Ross. Okay, so Ross. Okay, it's setting up stuff.
I see. That SB that save Lisp and die.
Mm-hmm.
It looks like you'd want to use it. You kind of want to load this. Okay, there's a thing called an ASD, which we have to figure
Okay.
out how to make. And then once we figure out how to make this ASD from the file, all right.
Okay. But see, Ross helped me set this all up, so now I can kind of do it with Ross. I don't know what Ross can do for me right now. You can run REPL. You can do Ross build.
Let's see.
ASD, and then you should do hello Lisp. Okay. Unhandle hello Lisp is not inaccessible for build. Why is interesting? Why is not acceptable for build? It's just not acceptable for build. At least Ross doesn't like it. So I would imagine you need a specific type of what is it called? Like your Lisp file has to be in a specific format, I guess.
I think the way to do this is with this thing called ASDF, but I need to figure out what this is.
Okay, doesn't matter. Hey,
So let's just use the REPL.
runs. It runs. I'm happy that it runs, and thank you so much, Stephen. You got me to run some Lisp code.
I think you got a lot further than I did. Well, I'll show you what I've got going on.
Yeah, I'm gonna stop my screen share right now.
Simple. That's demo 2.
Okay.
.lisp. Now let's see. Let me present mine. Window. Here we go. Okay. So let's see. Is that the legible size?
This could be the start of a beautiful program, Stephen.
Well, let's see. Let's do a classic.
Okay.
+1, 2. Now, this is an Emacs mode called Sly. So if I do Control X, Control E, it has sent that to the running repo here. So I should be able to do something like defun. Let's see. Add number.
Okay.
Let's see. Add 1, 2. And let's give it no variables. And have it do a +1 and 2. And let's. Okay, so now I have done Control X, Control E, and that's given me this little notification right here at the bottom. This add 1, 2. So I should be able to call this now as add 1, 2. I don't think it's case sensitive. I got 3. So there we go.
Okay.
We've got a function here. So
how does this function? Okay. So the entire function needs to be in parentheses as well. See, this is what freaks me out about Lisp. The amount of parentheses, like, so much potential trailing issues here.
So I guess this one is gonna, and you need Emacs to kind of help you keep it all straight. So right, this is the function arguments.
Okay.
Right, and so if I can do something. And this should be the same, right? There's no meaningful white space here.
Okay.
I do add 1, 2. It's the same thing.
Nice.
But I should be able to do something like defun big add.
Okay.
Which is going to be something like plus. Can I do something like fun call add 1, 2? I'm curious if this is going to work.
So you're basically adding functions as parameters here, right? No, not parameters. You're just calling the.
I'm just
calling the functions. Okay. So it's a recursive thing. Okay, so you're calling a function within a function. Okay.
Variable add 1, 2 unbound. Oh, because I shouldn't need to do that. I should be able to just do. I should just be able to do that.
Yeah.
Because I'm not calling a variable. I'm just calling a function.
So calling a function. Mm-hmm. Okay.
Let's see. Big add.
Look at that. Okay. Awesome. That looks pretty cool.
Now, let's see. Function arguments. If I did generic add AB, right? Should be able to say like plus AB.
Yeah.
So it should be like generic add 1, 7, 8.
Oh my god.
Oh man.
coming out of some Rust. This seems like such a free for all. like no types, no checking, nothing. It's just like, it's a function generic. Just pass whatever you want to it. Like,
and I should be able to do like if I have extra things, it should just ignore them, right?
Right.
No, invalid number of arguments. That's good.
This is really cool. Again, I've been drinking the Rust Kool-Aid for the last couple of a long time, and I got used to so much like very strongly typed languages, and like not just strongly typed but like very secure, like in a sense like everything has to be in a very strict order, and a lot of controls in between. And this seems like a very much you just
Oh,
throw
for
whatever you
sure.
want
I
at
mean,
it.
like
Yeah.
I used to do a bit of Haskell work. It's like if you were to do this
Okay.
in Haskell, right? You do like add that. Let's see if this will work. What was my Haskell sentence? You'd be like generic add, and you have something
Okay.
like this.
Yeah. Yep. That's how Rust would work. Yep.
And you do generic add AB equals A plus B.
Yep.
I
Well,
don't have Haskell mode. Shame.
look at that. Where's Haskell? Amazing.
Haskell mode. One second here.
I hope people enjoyed the operating system called Emacs right now.
And let's revert buffer.
And let me show you a little tidbit. So I have a book called Learning GNU Emacs, right? So this is a book called Learning GNU Emacs. It's a hefty book. There are, let's put it lightly, there are 532 pages.
Is that volume 1?
And this is VI, and it's a shadow of this whole book. So there is so much more complexity and capability when it comes to Emacs. It is insane. This book barely has 150 pages, and it's small. So yeah.
I do want to see the customizations you've done to your VI. It looks really cool.
Oh yeah, I'll be happy. I've spent time and effort making it look the way I want it to look and making it do the things I want it to do. So it's always cool when you see that. It seems very impressive. It is to an extent, but that's why I kind of like you get used to like you're used to Emacs. Like I just love working in it, and it feels so natural to you. Well, for me, like I don't know what's happening here.
So, it's just built in, right?
Exactly. Yeah. So,
oops, I just minimized my Emacs. It's the Mac shortcut keys that I'm not used to still after only just a couple of years.
Yep.
All right, let's open up our demo 2. Okay, so we've got some add functions, but we might want to do more than that.
Okay.
So now let's switch gears for a moment to this century, and get into Bedrock. So let's unshare this, and I'm going to present a different.
By the way, while you're doing that, let me just show you quickly what the add function looks like in Rust. I'm just gonna quickly pull it up here.
Yeah, let's see it.
So just if you can, yeah. So this is add 2 numbers, right? Basically, you have to define what the parameter needs to be. Well, actually, this is add 2 to a number, but like your parameter needs to be defined as what kind of a variable, the int32, and the output needs to also be defined as an int32, right? It's very much highly controlled. You can also do weird things like with, where did I put that, lifetimes. So Rust has a concept of lifetimes, like on a function that or a struct or something that does something weird with life, because variables expire and go out of scope. So you need to tell a function, hey, this variable, this is its timeline, the A timeline or the B timeline or the C, whatever timeline you want to say, and this is how long it's valid. That means if you get a variable that's not within that timeline, that doesn't fit into that scope, the compiler goes wild and says like, nope, that won't work. So highly regulated, let me put it that way.
So, no, I love type safety. That is a great way of. And I grew up on Perl, where it's like, oh, you have a string that just has numbers in it.
Yeah.
Try adding another one.
Yeah, it'll work. yeah. So like this function here, like you have the x parameter needs to be a pointer to a string that's of lifetime A. The same goes for y. Also needs to be a pointer to a string that's a lifetime A. The annotation that comes in is a generic trait that you don't really care about. Then the output is going to be this, and the output string needs to be a type that supports a trait called display.
So you can print
like
it.
Yeah, And if it doesn't, it just freaks out, right? So that means, like, for example, if I would run this function somewhere here, I don't even have it defined here, but if I would run this function somewhere outside of the scope where both x and y are not in the same scope or do not belong to the same lifetimes, like x is in a function and y is somewhere else, the compiler just won't work. Just say, yep, nope, they're not in the same lifetime. They're going to go out of scope and they won't work. So it's incredibly safe with what it does. It takes you a long time for you to get used to it. And I'm still trying to get used to it with referencing and dereferencing and all that kind of fun stuff. But
what do you work on building?
Oh no, I'm just learning. This is me just going through. Actually, let me show you. I want to show you something. I'm doing like 100 days of code type of deal, and I've done. So here is my little notepad or scratch pad. You don't even see it. Wait a second. Let me stop the screen share. Present once again. Three. Okay. So bring it up when you can get a chance. So this is my little scratch pad of all of the stuff I've learned when it comes to Rust. And I just go through a book, and this is how I write notes. All the code samples, everything I can try to do. It's just literally me. And this is like 20 days worth of coding. So it's been a lot. Because again, Rust is a complicated language to get into because it has a lot of moving parts and a lot of things you need to learn to be able to kind of properly do Rust. But once you get into it's really, really, really good. So
and the neat thing with Rust is that you have SDK support for most things because it's hit that critical mass.
It has.
Where there's going to be an SDK.
Absolutely. And again, it's just great. And I mean, again, you potentially wouldn't do web applications. You can do web applications with Rust. That's not a problem. But you will see a lot more complex things and backend stuff written in Rust because it is just really, really fast. It can optimize like with C or C++. You work on optimizing like where your data sits. Is it on the heap or is it on the stack and all that kind of stuff? So you can do a lot more optimization when it comes to writing code. Or you don't have to, but you can.
And there is the concept of like WebAssembly to Rust, right? Like you can do that.
Yes, Rust can do WebAssembly with a project called, I think it's called U or something like that. But yeah, they have a bunch of WebAssembly stuff where you just write WebAssembly. And again, it can be really good, and it feels nice. I kept telling this to people over last couple of live streams. Rust makes you feel smart. Because I don't know why, but it literally just kind of teaches you how to do Rust. Like the compiler itself is great because unlike some other compilers, and I'm looking at you, Python, that it just throws the Python errors usually just a blast of stuff you don't really know what it is. The the Rust compiler is very good because it tells you, hey, here's what you did wrong. Consider doing this. So it helps you fix the problems. And the community is just crazy big now. So yeah.
There was an awesome language called Elm, which was like a simplified Haskell that compiled the JavaScript. Yes. I really liked that. And that had the same thing in terms of great error messages. Unfortunately, they had a little bit of a schism in the community.
Yeah.
And they haven't really recovered from it as far as I can tell. Like it's a neat language. I really like the Elm language. And if I had to make an app with a front end, I'd probably reach for that. Like if someone had I don't know, if I was being held hostage and the way out was a web app, that would be the easiest way to do it. But
I agree. I agree. Like some of the languages out there are really cool, and so one of the things that I've learned about Rust is that one of the benefits, and I keep telling this to people, is 1 second. Let me show you. Is there? I have a thing somewhere. I want to see if I can showcase this. Yes, CD adder. One of the great things it has is it has automated tests built in. Right. So like you don't have to use an external testing framework. It has automated tests built in. And the way it works is that, again, I'm going to share my screen. The way it works is that that you like. For example, this is my library file. Think of this as the header file in C, right? The .h or whatever. These are my functions, which are going to later on be used like by my main function, which I don't even have here, right? But my main file is going to be using these functions and whatever function structs, methods, whatever. And then literally in that file, you create a thing called module called test, and then you just call any of the functions within this specific header file or the library file, and then you label it, you annotate it as a test. It says, okay, run the function here and just add 2, and you expect that the outcome is going to be 4. So if you do cargo test, it should say, oh, yep, it's done, it passed, beautiful, right? And this means you can do both. You can do both integration tests, and you can also do you can do unit tests, and you can also do integration tests. So this is an integration test which just loads your entire library, loads your complete cargo crate, and just runs it. Tries to do it the way you do it, whatever, right? So really great, because you can really adopt the test-driven development functionality here without having to rely on like third-party packages or something like that. So
yeah, that's cool. That's really good that you can have that right there and have that.
Okay. I'll stop swooning. Let's go back to Lisp. I think we're just getting really off track here.
Let's give this. Okay, well, I'm going to share.
Okay.
Postman. Okay.
Yes.
So one thing you'd want to do, and we want to recreate this in Lisp, is it is calling the list foundation models endpoint. And so this is going to give us a list of the possible models that we could then use. So we get this JSON of model summaries, where, let's see, for each key, we get a model name, output modalities, model ARN.
Okay.
And then if we wanted to use one of those, we go, this is if you search for AWS BedRock Postman, this is all nicely set up for you. So say if we wanted to do a text generate text. So it should be able to say, let's see, generate blog.
Okay.
So the body of the post is
a
standard prompt.
Okay.
Let's see. Write me a blog post comparing Lisp and Rust and Python. Make it sarcastic.
Okay. So what you're seeing here is this is the JSON object we're always passing to Bedrock. No matter how you're calling Bedrock through the SDK, through the UI, you are literally just always giving a specific model this specific what is it called, a JSON blob.
So. And so let's look at the whole thing. Let's see this. Okay, so right here I'm calling Titan-tg1-large/invoke. Okay. I'm going to bump up the temperature. I want it to be creative, and so I'm going to put it to 0.8. Okay. Temperature is how far it's going to wander. So let's hit try. You don't have access to this model.
Right. So you need to authenticate somehow, right? You need to do authentication.
I've authenticated. I think I need to sign in. I'm in US East 1. Give me 1 second.
Oh, so okay. So make sure.
Model
right.
In that
so
account.
Yeah, exactly. You're using Titan TG1 large, so maybe that is not the model you have access to, right?
I think. Let me double check. It might be that I've enabled it in US West 2, and if so, I just need to click on something. Off screen, I'm going to the AWS Management Console. Then, let's see. Definitely keeping this part off screen. Let's see. MFA. Nope.
Share us your codes.
Yeah, I'll just, out of the goodness of my heart, give a public API key for Bedrock.
Please.
As a public service. Let's see. So if I'm in US East 1, Amazon Bedrock, actually, I should be able to share this now. Let's see, base models. Let me share this screen. Stop screen here, present, share screen. Here we go. So I want Titan text generation 1, TG1.
Okay.
And it says this account currently does not have access to this model access.
Okay.
So I can available to request. Let's request this. I can request this. Where? Manage
So
model access.
yes, that's how you do it. You take it off. Yep, there you go.
And let's click. Let's just be greedy here. Let's take everything.
Yeah.
Llama command. Why not? And let's see what happens. I think some of them might actually email me stuff from the App Store.
Yeah.
There we go. Access granted to TG1. Nice. So if zooming in here,
Okay. Yep.
Titan. So now this request should work. So stop screen here and then present the Postman screen. There. And then looks promising.
Okay.
Looks promising.
Okay.
I mean, it has a lot to do, right? It's comparing.
Exactly. So it is generating a bunch of stuff. By the way, how do you get the model ID? I need to figure out how to get the model ID. Do you just do AWS BedRock list? Oh, look at that! Wow.
And the great debate: Lisp versus Rust versus Python. And then since we've bumped up that temperature, it's doing funny things like let's compare these programming languages so different from each other. They might as well be from different planets. Lisp is known for its parentheses heavy syntax, which can be quite confusing. Let's see. It has a rich history of being used in computer science. Rust is relatively new. What is it saying about Python? Python is versatile and easy to learn. Okay, fair enough. It wasn't as sarcastic as I wanted it to be. But it worked.
Okay.
So now the question is, can we do this in Lisp?
Okay.
So in order to do that, let's get back into Emacs. So what we've proved here is that this particular set of credentials, which are safely hidden off the screen, do work. So we need to recreate a post request. Well, let's first start with the list custom models. So list custom models is a GET request to this URL.
Okay.
So
you can do list, like list custom. Okay, right. List custom models, right, or list foundation models.
Oh yeah, sorry. Yeah, list. Oh, sorry. Yeah, let's do list foundation models.
Yeah.
So let's share the screen again. Share screen. Okay.
How does it send the? I wonder. I mean, Postman probably wraps something in a call, but how does it send the credentials? Does it also do SIG-V4?
Yes, Postman has something built in called AWS authentication.
Okay.
So.
Okay, so we need to figure out. Okay, for us, what we need to do is we need to sign this request, right? So that's the whole thing, right? Right. Okay. Okay.
SIG-4. So let's give a quick tour of this this code here. So for Lisp to work, well, we're using this thing called Quick Lisp, which we learned yesterday. We are loading these libraries. So this is the signing library. Drachma is a web request library. Flexi streams is how to parse some of the output type, and then CL plus SSL is some of the what do you call it? This is the underlying dependency for making HTTPS requests. So if we run some of this stuff in our REPL, sly mREPL here. Okay, let's have a look at this. We can load up sign4, Drachma, Flexi streams. Okay, let's do a request to HTTPS google.com just to make sure everything's working.
Okay.
And that seems to work. We've gotten a web page. Got that seems like we've gotten something.
Okay.
Okay. Now let's go back to the REPL. Okay. This is a cool thing that's going to allow us to debug the requests. If we need to turn this on, we can.
Okay.
Okay. So now the function here, bedrock request. This is okay. So multiple value bind. What this is saying is okay. So this is going to get into the Lisp
Okay.
a bit.
Okay.
So let, right? This is saying, and we can format this slightly differently. So let is a binding. So notice that the end parenthesis for let is that one over here.
Okay. Okay.
So just to kind of
okay.
open this up. And let.
That, thank you. That name. That's what we need. Yes. Okay.
There we go. And then this one here is going to be end multiple
Flex.
value bind.
Okay. Okay.
So the let here, the first thing in the let binding is it's going to be a list of things. It's saying within the scope of this is going to be like the let function block.
Okay.
So it's saying, let's see, let step 1 bind the list of variable names to their expressions.
Okay.
So we can also, as an example, oops, I just turned on dictation mode. Here's a variable name that it's binding. We could bind another variable called, I don't know, programmer name, and bind this to something like this.
Okay.
Right. We could.
Okay.
And so this is just a way of binding variables. And so it says once these variables are bound, put them in this scope. And so now multiple value bind is saying call a function and then take the resulting values. So this function, the function in the second argument to multiple value bind is going to return 2 values, assign them to these things, auth z and date.
Yeah.
Believe that's what's happening. So, and let me double check. So I think we can do, let's see, slide autodoc documentation lookup.
Okay.
Oh, interesting. That took me to a web page.
Look it up, Stephen.
Slide describe symbol. Here we go.
Okay.
Multiple value bind names a macro, and it is saying, okay, lambda list. Okay, so it's saying variables. That's this one.
Mm-hmm.
This is the value for. Oh, okay. I think what it's saying is at the end of this, these variables will be set.
Okay.
I'm not 100%.
Yeah. Okay. Okay, so it makes kind of sense. So what it does, the auth z variable is going to be anything that comes out of the AWS sign for function, right?
Mm-hmm.
That's going to be auth z, like the auth headers, I guess. And then the date is going to be, I don't know what the date is going to be. I don't know where
so multiple value bind, it's going to call this function.
Yes.
This function is going to return two
things. Okay.
It's going to bind them to this and this. Then those 2 things are going to get passed into this function.
Okay.
So what it's saying is this is how it's kind of generating the request, right? It's saying this sign for thing is going to return a date in this XAMZ date. So it's the exact date that Amazon wants.
Mm-hmm.
And this authorization thing, which is going to be our signed token.
Okay. That makes sense.
Okay. So now this is going to work because of the following stuff, right?
Okay.
Credentials from file. It's saying open up a file located in my home directory, .aws.special. The first line is the access key. The second line is the secret key. Let me show you the contents of this file. No, just kidding.
Okay. Yes, please.
And then the next thing it's saying is this package called AWS Sign 4 wants to have a function. It has a variable called AWS credentials, and in the documentation of the documentation for this function says assign this variable to a function which returns two values, the access key and the secret.
Right.
And so the idea is this credentials from file, it could be a number of things. It could prompt you for user input. It could look it up in a database. It could try to access your Apple keyring. A lot of different things depending on how you want it to do it. And so this is the flexibility that Lisp is getting you.
Okay.
Okay. Then this macro with AWS credentials, this is saying, so this is kind of another way of doing this. It's saying, temporarily, since if you don't want to bind this whole thing kind of forever globally, what you can do is saying, for the context of the input function body, bind this function to this.
Okay.
Bind this variable here to the credentials from file function.
Okay. Okay.
All right. So let's try to modify this bedrock request, because before we were trying to do, okay, so this is taking, in this bedrock request, the region is going to be US East 1.
Okay.
So let's make sure we've got that programmed in correctly. Where is this? Region. No, that was a debugging thing. Here we go. US East 1. List foundation models, empty request. Let's call this test 2.
Okay.
And then what I think we want to do here is, this is a method. This is a get. And this is a get. Now, the HTTP request that we're making is to host. Now, host here
is the format. Yeah.
This we need to change to /foundation
models. Yep.
Now, this XAMZ target, I don't think we need that, because looking at, let me double check the Postman real quick.
Yeah, check if you can see what is the actual API call it makes, right? Like what is the signature or something like that, right?
Yeah. And if I need to, I'll share my Postman screen. Let's see.
Okay.
Hidden headers. No, okay, it doesn't have that. We don't need it has XAMZ date and authorization, but we're not using the XAMZ target. So luckily the syntax is so friendly that we can just delete exactly what we need and be sure that our parentheses are still balanced.
Okay, good. Okay,
so let's put no reason for this to span multiple lines. Okay, so we're giving it this header of content type XAMZ JSON, and then signing that request. Let's see, do we need, that XAMZ target we can get rid of.
Okay.
And then that properly terminates, and then same thing in this list. Right, this XAMZ target we don't need. Okay. Let's open up our... So let's evaluate this function called bedrock request.
Okay,
that's done. Now credentials from file. I'm going to evaluate this parameter. Variable credentials from file is unbound. You know, I was experimenting with it. I don't think we need to do this because the macro is going to give it to us.
Okay.
So now here's the macro.
Okay.
We load up all these packages?
I don't know.
Yeah, we did. I'll just load them up again. Lexi streams.
Okay. But how did you fix the SSL thing? Like we needed that C++ SSL, right? That's the okay. Yeah.
I just had to
we had issues with the CSSL. Yeah. Okay.
Okay, so I think we can run test 2, and if everything works well, we should be able to see a list of models. Test 2.
Okay.
The request signature we calculated. Please check AWS access key and signing method. Okay, so the good news is we're communicating with Amazon.
Okay.
The bad news is our signature isn't quite right.
Okay. What kind of? Oh, so we're not generating the correct signature, right?
Yeah. So I wonder if in the AWS sign for, I noticed I deleted something out of the header that we might have needed in the signing. I wonder
Okay.
how that works. Because do we need still an X Amazon target?
I would imagine. I don't know. Like, I mean, have you seen the the Postman? Like, can you see the raw?
Here,
Can
let
you
me
see
share
the
that.
raw header? Okay. Just make sure
Let's-
there's no credentials in the header. So
No, there isn't. And this is a temporary account anyway that I'm going to delete. So let's try this. Where's StreamYard? Okay, so if stop to share that and then present share screen. Here we go. Okay. So looking at this foundation models, if I look at the headers.
Okay.
Oh,
There's
sorry.
request ID.
That's the here's the request headers. There is an AMZ date.
Okay.
And there is the authorization.
Okay.
Credential.
So,
that is kind of okay. That's not my full thing because it's signing
it. Just use it. Yeah, exactly. Yeah.
Signed.
It has X Amazon date. It has X Amazon date, so that's okay. So what did we remove? Which is the one that we removed?
So in the signature generation, I removed a header called.
Okay, which one?
The header was
X Amazon something.
I removed X Amazon target, X AMZ target.
Okay, so this could be something related to because so what we did here is we took an example from what is it called? We took an example from simple workflow, like a little Lisp function that was sign and do something with simple workflow. So let's see, Lisp AWS for. So I want to see what that thing was. Maybe we can determine, looking at the original one, what that thing was. So X Amazon target is something we removed, right?
Yeah.
It says format null, simple workflow service, the action. So it is, I would imagine it is something that we have like BedRock here, like in the headers. I don't know. Let me AWS BedRock API reference. So actions, BedRock, list foundation models, request syntax.
I think we can actually do. I think we actually can use this.
Okay.
BedRock. What is this? Simple workflow service. I think we can actually just do. I think we can just say BedRock. I think. Let's give this a try.
Okay.
I think that is correct. Now, that might. Now, ideally, what we're hoping is that this changes the signature into something that makes sense.
Okay.
Now, let's give that a shot. Okay. We'll run test 2.
Yeah. So in this case, we I don't think we. I'm looking at, do we need a target? I'm looking at how do we sign, right? How do we sign? By the way, we don't see your Emacs. We see Postman, just so you know.
Oh, sorry about that.
Transfer payload in multiple chunks, signature, calculation. So it's the X Amazon AMZ target, right?
Yes, XAMZ target. And so actually, I think I should be able to test this. If I do, again, this is print credentials.
Okay, no. So the X Amazon target is basically the service dot the function we're calling, right? In this case.
Yeah.
So that would be bedrock dot list foundational models. But okay, I'm looking at an example.
Oh, okay. So I should be able to do this bedrock.list foundation models.
Yes, but I think bedrock starts with a capital B. At least in other examples, it always starts with a capital letter. So they like use a camel case. Yeah, maybe that's the case, right? List foundation models. Yep.
So I wonder then, how does
Maybe
Postman know how to do that?
So also looking at the format in the host, you don't need to do the foundational models, right? I think the target is being X Amazon target is handling that. So like on host format, the way we have the URL, remove the foundation models. So right, so even remove the trailing forward slash. So on where you have the bedrock URL, so bedrock dot tilde a. You need line numbers, my friend. That there,
Here.
yes.
But I guess, but how does it know? Because look, the actual request it's doing is to host,
right? But I think I think the headers do that for you. I mean, I don't know. Looking at the Lisp example we're looking at. So, for example, one of the things that the Lisp example has is what it does is it takes a region action payload, right? So, like you have printed your credentials out.
I
Right?
see that.
Clear.
I want to expire these soon enough.
That's fine. So for example, in the example we're using, by the way, it uses the function sfw request uses a region action payload, right? As its parameters, right? What is our what's our function? How does our function start? Right. So yes, good. So right, it also has a thing. So okay, so headers on the headers side, on the headers where you added just Amazon X Amazon target, just remove dot list foundation models. So yeah, so
it's
on
here.
the headers, yep, just remove that and put dot tilde a, like the little variable substitute. So tilde, the little squiggly line, yeah, and then after the parentheses, add action, because we're going to be taking the action parameter from the function. Right? We see. Right?
Yeah. Okay. So that's if we wanted to. Okay. So now I need to wrap it in that whole format.
No. We're doing it already, right? So we're already doing it. So I'm looking at the example here, right? So because the bedrock request takes the whole thing, right? And it passes the action payload. Like you have the region payload, the region.
No, I guess what I'm saying is I need to do this. I need to do format nil.
Yes.
Here. Yes. And this is tilde a.
Tilde a and action.
And then action.
Right. And you need to do the same thing
here
on the additional headers. Yep.
39.
Yep.
Let's see if this is gonna work.
Right. Okay. And then also on the line where 2 lines on the left, the host where you format the URL,
here,
remove foundation models and the trailing backslash. Also the yeah, that's it. And then you see if you go all the way down to the where is it? Where do we call the function?
Over on test here. Sorry, test
Right.
here.
So on the test function, you see that we call it SW request with EU West 1 as the first parameter, the region, right? Second parameter is the action or list foundation models. And then the third one is just a blank body, right? That's it.
But I guess what I'm trying to figure out is like in Postman, the request that we were querying was just foundation models, not list foundation models. We were querying this URL.
Okay. Maybe it's doing something with like the actual path in itself. I mean, you can do it through a path, right? So like you can just curl that path, and it's gonna say no, it doesn't work. But you can also potentially just pass it as an X Amazon
All right.
target as well.
Let's try it.
Yeah.
Okay. So then, if I open up my REPL,
Mm-hmm.
recompile that function, I should be able to say test2. Format is not a type character type error. So what do I? We did something here. Format nil action.
Which line?
It didn't give me a line. It gave me a. Let's see. In BedRock request, let here. Style warning. Let's see. No, here. Test2. Here we go.
BedRock action. Okay, so it is format nil action. Okay.
The value format is not of type character.
But it should be. So when you call test2, the test2 should be just passing a string, right?
Yeah, let's see. Let me find that example of when we did use the format correctly.
Mm-hmm. Yeah, I mean, test works perfect. I mean, like looking at this thing, BedRock request with AWS credentials, we call it list foundation models, right?
Format nil something dot tilde a action. Format nil something dot tilde a action. That looks right. Oh, yep. This is going to make a lot of sense. There has to be a comma right here to change the quasi-quoting method.
Ha 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 ha. Okay, make sure to update. Yeah, okay, good. Okay.
Surely we would have picked up on that.
Of course.
Test2.
Ooh, unknown operation exception. Okay, so that is good because that's a response from the backend.
Yes,
from the endpoint. Okay.
So
good.
But I'm still confused because we're not querying the same URL. Let me try have a look at this signature to see what signature we're generating is.
Okay.
So I don't want to. Okay, so this is with AWS credentials. So if I instead of call, okay, so AWS sign 4. This AWS sign 4. How does this work? It's this. I want to see what happens when. I want to see what auth z and date look like.
Okay.
So if I took this, actually, what I could do is just look at the header stream here, and let's try that again. Test2. Okay, so here's what it passed in as authorization here, signed headers, content type. Okay, so I'm going to copy and paste what came in from Postman so we can compare that. So that's the authorization header.
Right. But the X Amazon target is not. So do we see the target? We don't see the target. Oh, we do. X Amazon target is BedRock list foundation models. Okay.
Okay. So this is from Postman.
Okay.
And then let's compare. This is what we're generating here. This is from Lisp.
Right. So it's not doing X Amazon target in this case, right? We can potentially ignore X Amazon target in this case and just target the URL itself. Maybe that would work, right? Because you can just target the URL with HTTP, right? So like, then the option here would be remove the X Amazon header, X Amazon targets, and then just target the URL from the first one, right? So like in this case, the format of the bedrock URL has to just include the list dash foundation models.
Yeah, so I think what I want to do, let's try this here.
Right.
So I'm just going to do hard coding here. So we want to do
Foundation models.
slash foundation dash models. And then we want to get rid of the Amazon target here. That looks okay. Get rid of the Amazon target here.
And then technically this should look like a proper call, right? So run that and see what we get, what kind of a signature we get.
So then I have to do this. Define test LR, no options, and I have to say with AWS credentials. Yep. And then let's just double check the syntax for that. Yeah, okay. BedRock request. It's going to look like that, but okay. Now I'm taking the argument, but I'm not doing anything with it.
Yeah. It shouldn't cause any issues, right? I don't know how Lisp is to that, but yeah.
Yeah, so I'm not using the action in this one or the payload.
Right.
Okay, payload here. Actually, I am using the payloads. This is an empty JSON. Let me look at the request body here. Body here. Oh, there is no body. So just to make it as similar as possible, I'm just going to make this that.
Okay.
Let's see. Oh, and this is bedrock list request. Let's compile this function here. And then go back to Sly. Test LR.
Okay. Invalid signature. Okay.
Okay, now let's look at the signature that we're generating. Credential here, AWS request. This is the signature. Interesting. Why did it not like that? So copying this one and looking at, this is the Postman one above us. Copy the whole thing. Oh, this.
Yep.
Credential, that looks about the same.
Yep.
Side headers. We don't have an accept header.
Right. Okay. Interesting. Okay. So maybe because this example that we're looking with is that this is also like a list domain. So this one is doing a post method, right? So the example we have is a post method. Maybe we need to add another header called accept.
Right? That's what I was thinking is, let's see.
So you can do it in the additional headers, I would imagine, right? Or content or
I wonder. Yeah. Okay. Yeah. If it's additional headers, because we don't need, or do we need to sign it? No, because this is coming into the signature.
Yeah. Exactly. So
we
you can just do accept. Yeah.
In here, right?
I would imagine.
But now the question is, what goes in the accept header?
I don't know. You can just leave application JSON or something like that. What like can you see? Yeah, maybe if you look at the Postman example, maybe that will show you what they have in the accept header. I don't know.
I think that's all hidden behind the Amazon signature.
Okay.
Let's just try. Getting close. I can feel it.
Okay. Yep.
Okay. So now, what do we have in our headers here?
We do have the accept header.
Accept.
We have content type, which they don't have. Like, we don't need the content type technically here. You can remove the content type. The reason is we're not sending anything. We're just getting. So yeah, that could be a potential thing.
We're zeroing in.
Okay. Yeah. Of course. This is how development works, my friend. Right? You just try and try.
Let's see. Oh, we're getting close. What is this here? So then we have this. We have content type signature. Let's have a look here. So now we have that
That looks
credential.
exactly the same, at least in the headers.
Yeah, these look.
Yeah. Interesting. Did you by any chance run Postman again, just to see if Postman is going to work, just to make sure that something hasn't happened to the credentials?
Yeah, that just worked.
Okay.
And let me look at the headers. Interestingly, I wonder if in the addition, do we need any? No. It's giving us a problem with our signature, right?
Okay. Yeah,
I'm
exactly.
trying to figure out.
Go back to the error, and you should see
Invalid signature exception.
Yeah, the requested signature we calculate does not match the signature you provided. Check database secret access key and sign-in methods. So maybe.
So it's possible that this AWS sign package, which has probably been used by one person,
right,
is not calculated. Well, are we calculating the XAMZ date correctly? Let's see. So this XAMZ date header, this looks a lot like what Postman is generating.
Yeah. Okay, so one more thing. There's a couple of differences. I'm looking at the raw request coming in from Postman, because they have a JSON file that explains that.
Yeah.
So the method is get, the header is accept. However, the content of accept is application/JSON, and not Amazon JSON, just application/JSON. So that is the only thing coming in a header. So yeah. Okay, that doesn't matter. Just making sure that we get that out of the way. So also, I love the internal error you're getting. Invalid signature exception. Internal.amazon.com Coral/com.amazon.coral.service. I wonder if Coral was a code name for this. I have no idea.
Actually, I'm gonna try.
Okay.
Accepting everything.
Anything? Okay. But I think ultimately the signature doesn't work, right? So that the signature is not correct. So I don't know how does it, like, my question here is because you need to do some calculations on the signature, right?
Mm-hmm.
So if you look at the example coming from this AWS sign 4, right? It's from a long time ago. It's from the last update was 4 years ago, which again should work. But I want to read the requirements. I don't think they should have changed too much, right? Like they should have been okay. Now the only challenge here, I think, is like maybe your local time now. Does it get the correct time? 21. It gets the GMT time. So
let's see. Well, this is what we calculate. Is
okay,
this
2024? Okay.
This is
So
21,
yeah,
18.
Yeah,
it looks about right.
Looks about right. Yep.
Let me share my Postman screen again. I think
Sure.
there are some slight differences in the bigger request header, which it could be the case. Wouldn't be the first time that it's not exactly the error you're getting isn't really the error that's happening. That's
okay. So let's do one more thing. So I'm looking at one of the issues that exist. When it comes to using GET requests, somebody commented, at least for Route 53, that you need to provide a payload. You need to provide an empty payload. Otherwise, you get nothing. So
well, looking at the Postman.
Uh-huh.
So here's the parameters. Okay, so here's the headers. So authorization is this signed thing. XAMZ date and Zulu time. Postman token. That doesn't matter for our sake. host. We're not sending a host header.
No.
We're not sending user agent. We're not sending accept encoding.
Okay.
We're not sending keep alive.
Is there something that's, look at the body or payload or something like that? What is being sent as the
Body is nothing.
empty? Nothing.
Now, if I did something like raw and did something like that,
Mm-hmm.
see, that's okay.
You still get something, yeah. So if you look back at your Lisp, when we're running test, the LR test, what's the payload you send?
It is currently nothing, but
Put
let's
parentheses, yeah.
the request signature we calculated does not match.
It's the same thing. Okay. I'm just looking at some issue they have on the what is it called? On the
GitHub?
GitHub repo itself. Yeah, they have an issue where somebody said, "Hey, get requests." So say in get requests, one must provide a payload in order to generate something, right? So yeah, and in your Lisp file, does your payload have a payload like a? Is the payload part of the signature?
Yes.
Okay.
So see that it's part. It passes it into the sign for method.
Yeah. Okay. Good.
And then it also passes it as part of the content.
Okay.
Headers. Let's see. Pre-request script. Test settings.
Okay, so the payload needs to be signed as well. Signing payload, you must. So I'm looking at the documentation for the signature version 4. So when transferring payload in a single chunk, you can optionally choose to include the payload hash in the signature calculations. Refer to signed payload. Payload. What? If you don't include it, the payload is considered unsigned. The signing process discussed the following section applies to both, but note the differences. Signed payload options include the payload hash when constructing the canonical request. That makes part of the signed to string, yada, yada, yada. You also specify the same value as the X Amazon content SHA 256 header. Okay. Unsigned payload. You include the literal string unsigned payload when constructing the canonical request. Okay. When you send your request to Amazon, this is S3 specifically, but okay.
So interestingly, so if I put a empty payload here,
Okay.
in Postman, are you seeing this?
Yeah.
Then if I recalculate the request, it adds an extra header here called XAMZ content SHA
Okay.
256.
So okay. So you need to do something about that. Let's go back. Let's go back to Lisp. I want to test something out. So we can do that. We can do that SHA 256 because it mentions it in the documentation, something to SHA 256, right? I want to go back to Lisp. So can you remove just the payload? Just remove payload. Just let's ignore payload completely.
Let's give that a shot.
Yeah.
Let's, you know what? Let's do it this way and
Yeah.
comment
Better.
it.
Yeah. Okay.
And then getting rid of it here.
Yeah. Because you're passing nil here, right? In this case.
Yeah, I was passing the empty string.
Okay.
But let's.
Okay, this doesn't work. Okay, so there is nothing here. Test LR BedRock list request. USist 1. Payload is not being used anymore. That is good. So let's see how that. I don't know how to do a X Amazon content SHA 256. I don't know what that means, right? Because there's something to do with that. Because I do see that as an example as well in the documentation. So.
Okay, this is dumb, but do I need to specify HTTPS?
I
don't think so.
Don't think so as well. No, you don't, because there's a format. It's Drachma. There's a Drachma thing. So yeah, it's fine. So in the Drachma line, you will see that it has HTTPS there.
Yeah. Oh, there we go. Yep.
Yeah.
Okay. I mean, we definitely don't have all the headers.
Right.
We're not passing content length. Let's see. If I disable content length and host and user agent and accept encoding and connection, I'm going to do this on the Postman side now.
Yep.
Yeah, one of those it wants.
Right.
So let me share with you this. Again, that's kind of interesting. Let's see, is this Postman? Okay. So if I add content length, host, user agent, accept encoding, connection, this works.
Okay.
But if I get rid of content length,
okay. Okay.
Look at that. I wonder. That's interesting. So you actually need the content length header.
Okay.
And if not, it will give you this. It's the
Okay.
So the question is, how do we calculate this? This header was automatically added. Use the request body tab to control the value or to remove this header. So how do we figure out how this gets calculated? It's
Yeah. I mean, I don't know. Let me look at the example, the Lisp thing, to see if it does that kind of a code. What is the name of it? It's content content.
I'm going to
content
do a quick experiment. Oh, okay. Well, I tried it said content length 192. I wonder, is there a way in? There has to be a way in Postman to actually see what that got substituted to.
Okay. I don't know. Maybe when you send a request, you'll see the whole thing. I don't know.
Well, if I hit send.
Okay. Right.
And then. How did you do that in Postman? Let's see. How to view calculated when request is sent headers. Postman console. Okay, so Postman. Ooh, I don't know Postman particularly well.
I don't either. I use it maybe a couple of times. I try to use all of my post and get requests, all of the API stuff I do. I like to use it through the command line, but yeah, it basically uses curl, right? To see here, you see the header, content type, content length, but it doesn't show you what is the content length. I think the content length is part of the signature, I guess, or something.
And interestingly, with the data, it is doing this raw. Let's see. Content. Wait, so where is that? That I'm a bit surprised at.
Is there a Lisp?
That's what I was looking for. Let's see. Assigned headers. This is so.
So this just runs the requests thing. It doesn't even calculate the signature. So like the code snippet here is just doesn't do the snippet calculation, right?
Yeah, I'm just curious to where this content length is going.
I feel the content length goes to the calculation bit, right? Like I would imagine. The same goes like with the, I don't know.
Okay, well, if I turn it off. Wait, how did this change? Let me see if the signature changes. Yeah, the signature changes whether or not I have content length in there. So I wonder if that actually has to go in the headers of AWS Sign 4.
I don't know.
Because if I did content length dot 0.
Okay. So I'm looking at the source code of the Lisp function, Lisp signature thing.
Yeah.
It actually handles content properly, like sorry, not content, the payload. It does all the stuff it needs to do. So it should be okay. Like it should be able to sign based on the content, but something else is preventing it, right?
Yeah. Okay. So something.
So like let's just remove all the content. There should be nothing.
Oh,
you
I
just
see.
pass an
You
empty
can't
string.
see my.
Yeah,
I keep switching through the Emacs. Let me stop that. And and I'm also passing it nil when I really want to be passing it.
Yeah, just an empty string. Just an empty string.
Okay. Let me stop sharing. Where to go? StreamYard. Let me share my Emacs window, and I need 30 seconds. I'll be right back.
Okay. I'll entertain the people. So while Stephen is doing that, I'm going to talk to you all about Lisp. I'm just kidding. I have no idea what Lisp is. The only thing that Lisp's kind of, the only connection I have to Lisp is I know Emacs is configured using Lisp. And I believe Richard Michael Salman, RMS, Richard, yes. He's a big fan of Lisp, and he thinks Lisp is the best language in the world. I I care to differ, but yeah. And also, I think one of the things I learned from Stephen since we started doing this thing is that there are many different dialects, or is it dialects? Yes, dialects of Lisp. So what you're seeing right now here on the screen, this is not the only type of Lisp. Emacs Lisp is different than this Lisp. Slightly, right? Like if you take the old book, just this says Lisp, it's mostly the same. However, Common Lisp, which Stephen is using, has a lot more functionality. And what that mean, I don't know. Right? So it's something else that I don't really know. But there you go. Welcome back, Stephen. I was talking about the history. Oh, he's not yet. Okay. Welcome back, Stephen. I was I was telling people the history of Lisp. So there you go.
Did it help resolve our content length issue?
Yes, exactly. So you see how the content length here is 192. So when you pass it, it says content length 192. Look at the call being made. So we do see a lot. Now, I think if you pass it right now, there should be no content length. Like just if you changed, okay, you can do that. But try to pass it right now.
Okay, let's try this.
Try running test LR. Boom. So content length is still 192, right? So
I think that's the content length of the response. I think this is my request.
Okay. Fair. Yes. Okay.
But then similarly, actually, this is interesting. Our request, we're not giving a content type. Whereas Postman is. Here, let me put the Postman
request. we did have content type in the past, didn't we?
We had authorization, but let me put the Postman request.
Yeah, we had content type. We had content type in the header. Yep, we did. So this was the content type. Let me show you in the original one. I'm sending it to you in a private chat here. That was the content type we had. So yeah.
Let's see. So what if we did in the... Okay, so where is our content type request? Oh,
that's a response.
That's the response.
So our
This is
content
what
type, yeah.
this is the request that Postman's making. So what if we do that? This
Okay.
is you're right. There's
But
a certain programming mindset that says we'll eventually figure this out.
yeah, but you're just gonna have keep hacking at it. So here's the thing. I think also one of the things we're missing the content type from the signature headers, right? If you look at the signature header of Postman, it has content type, right? If
Oh,
you look at
you're
the
right. Signed
right,
header.
yeah, it has a SEP. But okay, let's run Postman without data because this is the example you run with data. Please run it without data, just empty string, not the
Okay.
curly braces, just
Sent.
nothing. Um,
Wow. Okay, that actually shortens a lot. Let me give you the curl
exactly.
command here.
Yeah.
Okay, so this is no data.
There you go. Okay, so in this case, you can see sign headers have the accept, host, and X Amazon date, right?
Mhm.
We are having our headers do not have X Amazon date. The only moment they come in is in the actual
No, we do. Look, signed headers, accept, content length,
oh, we
host,
do. Okay,
XAMZ
we do.
date.
Okay,
I want to take out content length because I don't know what
okay,
that is.
okay. And put payload, add payload. Don't remove payload, add payload. We've commented out payload on the Lisp.
Okay. But we want that now?
Yeah. Of course. Yeah. Well, the Lisp program handles it correctly. Like it handles it correctly, right? So there's another one. Just make sure to put all of those things. There's nothing. We're just passing an empty string, so there should be nothing going there. Anyway.
All right, let's try this now. Test LR.
Okay.
Signature. Okay, so let's look at these payloads. We are sending
Accept
host XAMZ date. Same here. We've got a signature which is different in some way. We don't know how.
Yep.
We are sending a content length header
Of 0.
as 0.
Yep. Mm-hmm.
We're sending content type. Let's see. The headers cannot possibly be case sensitive, right?
No, I don't. No, they shouldn't be.
Let's see. We're sending a accept star/star.
Yep.
It really should be application/JSON. Okay, so we're comparing. This is what Drachma is sending, and this is what curl is sending that works. Now, just checking. Let's see if this still works.
What is a host in this case? How do we define a host?
Oh, interesting. So this signature has to be pretty accurate, like it has in terms of time, right?
Right. Exactly. Yes.
Okay.
I think the way it works, as far as I know, of course, there's keys involved and time. So keys, time, and everything, right? So
yeah.
It kind of so what happens is that the other side expects a specific signature based on your keys, right? And then only if those things are aligned, it's okay. Foundation model, and that should be okay, right? That should be fine.
And what is this question equals null?
You don't have to, like, it's just you can add things, like there's a bunch of stuff you can add, like additional parameters. I don't think you need to do it. I'm just wondering, so looking at your host, host is just the URL, never mind. Okay, never mind. I'm wondering what the host is, right? So host is just the whole URL. That is fine. Do we know what the host is?
Yeah, so that's substituting properly.
Mm-hmm. Okay, good. Okay.
Let's see. We're giving it a user agent, accept.
Okay.
Connection. This is in Postman. It's saying that connection is keep alive, but I don't see that in the curl headers.
Okay.
But it could be some kind of default thing.
Okay.
I do feel like we're kind of grasping at straws a little bit.
That's how it works, Stephen.
Let's see. Is there a connection one here? could just put it in additional headers.
You're missing a cup connection. Misspelled connection. I don't know if that's gonna work. Let's try, but yeah. Connection is keep alive, right? No, well, that's the response header is keep alive. Our connection is close.
No, we sent a connection of keep alive. Oh, what is this? How do we send them both?
Yeah. No, we have the close. That's the get. That's the request on the top, and the bottom is the response.
No,
the
look,
responsive is keep alive.
in our request, we sent a capital C connection with the close and an all caps connection.
I think it's a drachma thing. So
yeah,
maybe. Okay, so here's the thing. We're sending two headers here, right? Two sets of headers: the drachma headers and the AWS sign 4. So maybe that would work, but also maybe you have to do it on the signature, right? I don't know where that should live, to be honest. So
okay. Oh.
Yeah. So
okay. So drachma does not support a key.
Exactly. Content. Okay. So maybe go back into the sign before, and then in the headers there, add a header called what is it called? Yes. I don't think that's the case, to be honest.
No, I think, but isn't this only the headers that it's signing?
Yeah.
Okay. Well, I mean, it's worth.
Okay.
What are we seeing? Okay, so it's signed to the connection header, but
yeah.
In
so
our...
we don't need that. Yeah, we don't need to pass the. Interesting. I just wonder, like the example we have on the actual library we're using, they're using an ex Amazon target. I don't know, like if it seems that the Bedrock endpoint doesn't support ex Amazon target. I don't know.
No, it doesn't seem like it, because it's designed for. Okay, so let's see. Data, we're passing it an empty string. I'm looking at in terms of curl. The only thing we're giving it is accept application/JSON, which we are giving it here. We're doing that, right? We're giving it accept. No, we're giving it accept everything. Why isn't that? Do we have an accept? This is definitely not it.
You know what I'm doing right now? I'm looking at our SDKs to see how our SDKs make this call because they're all open source, right? So you can kind of go and see what they do.
AWS 4 request. I mean, the credential looks right. Signed headers, that's correct. Signature. I mean, we can't verify it, but it looks the same. Check your AWS secret access key and signing method.
Okay.
Is my Emacs showing?
Yes. Yes.
Let me stop this for a second. I'm going to double check to make sure I haven't done something stupid. Special. That looks like. Let's see. If I go to here, variables, that's the same key. That's the same. secret. Okay, good. Just make sure it wasn't something really foolish here.
Okay. Okay.
Okay, so the key and secret checks out. I mean, it has to be our actual signature.
I don't know. I don't really know. I guess so. I mean, yes, the signature is wrong. So what happens is that when we're creating a signature, we're not passing in something that we need to pass in, and it just doesn't do it correctly, right? Like I was thinking like maybe the date was wrong, but it's passing the exact same date. If you see the
Yeah.
request header, it has this exact same Zulu time as the response header, so that's okay. Something to do with what we are passing in. Now I have no idea what that is. So yeah.
I'm looking at the signature V4 page. I'm going to give this a quick scan, but I think if we don't get it pretty soon, we might have to call it for
Okay.
the day.
That is
Host
okay.
range date. What is this? Credential. The header names in signed headers must be lowercase. That's
Okay.
we're doing that. That's okay.
So interesting. X Amazon Target is a thing that's being used by our APIs. Like I'm looking at the JSON, like the AWS JavaScript SDK, right?
Mm-hmm.
When it makes an HTTP request, it has the XAMZ target header, um, um, and it also uses the application slash XAMZ JSON as the content type. So yeah,
You know
AP
what?
operations. Yeah.
This whole Postman project.
Yeah.
Let me look at how they're doing it in Postman,
Yeah.
because whatever they're calculating this on the fly.
Yes.
Let's see.
I mean, it should be a relatively quote unquote simple operation. It does, right? Like it's just a thing. So yeah.
Interesting. This isn't even in the Postman definition. This is so Postman knows how to do an AWS signature.
Right.
So
Let's see. Let's see. Resources, data.
service name, session token.
Nope. Photo 3.
Okay, I've found the GitHub code where they're actually generated, where Postman generates their signature.
Okay. I mean, yeah, you can do that. Again, you can always cheese this and have something else generate your signature, right? But you know, um,
Ooh, wow. Okay, this is. Oh, that's not that bad. It's only 300 lines of JavaScript.
okay.
Here, let me share this. This is actually kind of interesting. Method body.
this thing. I'm looking at Java now, and I don't know. I just can't decipher Java.
This is wow. Okay.
Yeah, it does put like, I see that the requests at least are being made with X Amazon target. So I don't know. But I don't know if that would change anything, right? So I don't know if that would change anything in our example. Because looking at the example we have in on GitHub is that it uses the X Amazon target just to use that as the endpoint target, right? So maybe we can change something here. Like how about you do something? Let's find something. Let's find X Amazon target. I want to
Well,
say if we can assign it, right?
but interestingly enough, so this is how Postman is signing it.
Yeah.
Okay, and they do not use X Amazon target at all.
Okay.
And 'cause I think that X Amazon target is when you're using the SDK.
Okay.
So what the what are they using? Let's see. Add auth data to signed request. Data to sign is this.
Okay.
They're signing a map with this structure.
Okay. Okay. So not every service has the X Amazon target. That is the thing. Yeah. There are some servers that don't use the thing. Okay.
And then so then what do they do with this data to sign? Data to sign. So they have this function.
Okay.
Oh, they have the sign function. So the sign function, what does it do? It removes a bunch of these headers. It removes these ones.
Okay.
It has this data to sign. And then where's the actual signature? Compute body hash. Data sign dot headers body hash header body hash compute body hash upsert header request dot body. Self dot add auth data to request data to sign. Huh.
Host. We need to include a host for our header. That is okay. I'm looking at the required headers for signature sign and stuff.
Yeah.
Common parameters, action, version, stuff. So can you show me again? Not sure if you have it handy or how easy it is for you to show me the parameters being sent by Postman.
Yes. Let's show that. Share screen. Postman. Here's Postman. So Postman is sending an authorization, an
Okay.
XAMZ date.
Okay.
And then it's saying
It's a
all this
token.
stuff is calculated when it's run.
Right.
But then if you actually tell it to give you the output,
Right. Well, it gives you the signed request, right? The actual signature, right? So it gives you the generated signature, not the way it generates the signature, right?
Mhm.
So it what it does, it actually in the back end, Postman signs it for you. Well, actually, sorry,
Yes.
Postman generates a signed signature based on the inputs you have here, and the
Yeah,
signature
exactly.
just needs to match the other side, and that's it. That's how it should work. So we do have accept host and X Amazon date, and we do have the same thing for our example, right? We are sending X Amazon date as well in the same format. Um,
Well, I guess are we sending too many headers that don't need to be there?
I don't think so. I think we're sending all of the stuff we need. Looking at the elements of a thing, of an API request, endpoint specification, action. In this case, it's kind of a different approach for us. We're not doing that. We're doing something else. Um, let's see. What else? The date. So the date. Specifies the date. You can use date or X Amazon date. It doesn't matter. It's the same thing. So for BedRock itself, it requires an action to be a parameter. Now, an action here is I don't know what. Like I don't know. Does it actually send an action? Like looking at the parameter sent by. So for example, are these all the headers? Like is that everything there? If you click on the settings in the request here, what kind of settings can it do? On the
In
yeah
this
in Postman. No, the other one, where the actual headers are.
here?
Yeah. So you have settings. Is there something here? No, on the top, up, left,
Where?
down, settings, next to tests. Go right.
Oh, here we
Uh,
go.
um,
I don't think
okay.
that's. But okay, so one
No.
thing that's interesting is that if I take off what was the one that I found to be useful?
Content length, but there's no content right now, right?
Yeah.
So like
So
that doesn't matter. So
are there any other ones that kind of kill it?
try removing the user agent, right? So um, it's fine.
That's
So
okay.
none of those things are problematic.
Get rid of
And I think
accept connection.
yeah, it should be fine. Even encoding, and I think even accept should be fine. If you do without the accept anything, because we're not like we're if you send a host, I think host is a mandatory thing. Like if you uncheck the host, um, boom, nope, it
Yeah,
doesn't know
that
where to
makes no
send it. Okay,
sense.
so yeah. Um, so the thing here that's kind of weird is the postman token. Now, what's the postman token? Can you hover over the little info button there?
This says calculated when request is sent, but it doesn't look like it actually puts it anywhere.
So
It's like if
it's
I
part
took
of
this,
it's part of the signature, right? So can you click on the little thing? What is this? Postman token header appends a random UUID to every outgoing request. Postman's not this header for API developers, just for debugging. Okay, never mind.
so nothing neat
Nothing
there.
important there. So it does something with the file, right? So it takes the not the payload. It does something with your credentials, the date, and so authorization. What does the authorization should be exactly the same as ours, right? Yeah.
One other. Let me double check the example. I
Sure.
think I might have done. I somehow. No. It injects the date automatically. That's not it.
Yeah.
XAMC target. We don't need content type.
I need to see SIG for AWS. What's the error we get? Is something like the signature does
Yeah.
not match.
Is it using the service name as part of the signature? It's got to be, right? So if I look at the Lisp code, okay, I'm still sharing Postman.
Yes. So
I'm
the
s-
Lisp code, the service exists. Yes. It's sending a service, right? SWF. So if you go back to Lisp, it should be something else, right? Maybe just Bedrock, or I don't know how does it do it, but it has a little SWF, right? Can you show Emacs again, or what?
yeah.
Whatever.
Yep. It's share screen window Emacs. There we go. Let's see. So I've just modified it. It was colon bedrock like this.
Okay.
But I'm wondering if maybe that's not actually.
Okay.
This is what I actually want.
Okay.
Credential should be scoped to correct service.
So just do
Interesting.
So just do underscore, just like a lowercase bedrock. But I think it should be the same. So
Well, I mean that's good though. I mean we're getting something different.
Yeah. Okay. Try using SWF. Let's change the service. Just to see. It's gonna fail on calling the API, but let's just right that.
I wonder if credential should be scoped to correct service.
Okay, so
bedrock.
it detects that, so it knows that that's the difference, right?
So
Because
it wants this to be bedrock.
Right. What if you send the method post? Just try post. I mean, it's not going to work, but try post.
I wonder.
Unknown operation. Okay, good. Okay, that's fine. So get. In Lisp, the column and the name, is that just a literal string, or what is that?
Yeah.
Like when you have okay.
I believe so.
Can you run the script again? So I want to capture the error.
Yeah.
Yeah, thank you. I'm gonna screenshot it. Check your AWS secret access key and sign in method. The request signature calculator does not match the signature provided. Like everything looks exactly the way it should be, right?
Yep. I'm so confused as to where, like, the signed headers are correct. It's accept host and AMZ.
Path. Change the path. Remove the path from the big old boy upstairs. Remove foundation models and put the path there. The example coming from give it a shot. The example coming from Lisp is not using a path at all. It's just using the target. But delete the one in the full thing. Delete. I think you should try to delete the one in the
host.
Thing. Maybe in the host. Yeah.
I see. Actually, I think what we should do, just for debugging purposes, I think this should be bedrock. US East 1 dot Amazon AWS.com.
Right. Yeah. Okay.
I think that.
Damn it. I was hoping that was the case.
I think that is still the right thing.
because it does pass the get foundation models. You see the get header, get foundation models, right?
Mm-hmm.
So that is a proper like if you look at the Lisp foundation models, it gets that, right? So try passing a little question mark. Try passing a question mark
Oh, on path.
on path. Yes, foundation models and then just a question mark. No, okay. Because if you look, okay, doesn't even apply to that thing. Because looking at the Postman request, can you see the get header for the
Yeah,
Postman request?
and they're actually saying it is well in the. Okay, let me show you what it's.
Yep.
Where did I put it? It's question mark equals null.
Okay. Try that. Try it. Why not? Question mark equals null. I mean, doesn't hurt. What is it? What is the get header here? If you scroll up, interesting. It still does that, but that's I
Well,
guess okay.
think if we do question mark equals null here,
It doesn't matter because we're not using that one. We're not using the host here, but right.
well, I guess that's the sign. Yeah, we're not using that.
Yeah.
We got a different.
Yeah, because we're getting the.
What is that %2f?
Oh no, we have to use the host. We have to. No. Okay. Go change this, please. Can you go back? Can you go back to the thing here? So leave the host there. I think you should delete the foundation models and the null stuff, right? Just delete all that stuff, and then we need to change the drachma. The drachma.
Call.
Okay, no, just change the host. Just change the host up on the host line.
Okay.
Just remove. Let's try removing everything from there.
Okay.
Yeah, okay. And I think that.
And so this could be just host now because that's the same thing.
Yeah. And then is there a drachma? Does it have a path also as well?
I
Can you do a
think
path?
we can do this. We can do foundation dash models.
Okay. Try it.
Actually, that's a good question. Does drachma Lisp I'm gonna see if it does have a path. Let's see, path. You're right that it actually could. So you're saying in drachma, we could also do something like colon path. Is there
Yeah, I'm looking at the thing. I don't think it. No, it doesn't have a path.
I don't think so either.
Yeah, I'm looking at the documentation, but it doesn't matter. So change the. Let's run it for running its sake. Okay, so if you look at the get stuff, it's get foundation models. Okay, that is fine. Let's change the drachma to be. Let's remove the foundation models from drachma, just to see what happens here. Right, just remove that, and also remove. Let's change the thing at the back at the sign before. Let's remove the question mark equals null. Let's try to keep it as clean as possible. Right. Okay. So this now we're basically telling it here's the path of the request, right?
On an operation exception. So this is here.
Right. Okay. So path is okay. So now in drachma, let's try to add foundation models, right? Maybe that's going to be. Okay.
Unknown operation exception. So what does that mean?
So let me have a look here.
We...
Oh, you need do you need a backslash at the end of the drachma stuff? I don't know if that makes any sense because
no, I'm more confused.
Yeah. So
Because
so mm,
this is like we're not querying the right endpoint.
yeah.
Oh no, I just misspelled it.
Ah. Okay. Okay.
Yeah, so that should at least give us the signature error. Oh,
Nope. Oh, there it is. Ha!
wow.
Ha! There it is. There it is.
That wow. That was
Ha! Yes, because the path is also part of the signature, right? If you do not include a path in the signature, it's busted, right? It doesn't sign it correctly.
yes.
So the path is one of those requirements, apparently.
I'm trying to find my big celebration gif. I can't find. Oh, let's see if I can do this one.
Does it work?
This is,
There you go.
wow. Okay. Well, now I knew we were on the cusp of an artificial intelligence revolution. And now we've got wow, interesting.
You know what this opens up the floodgates for, my good Stephen? Is
Every-
you are gonna have to create an AWS Lisp SDK.
well, now
You can just make an AWS Lisp SDK. That's it. It's done. You're done. You just go ahead and add all of the feature support, all of the services, and that's it. You have an
I'm sure
unofficial SDK.
I'm an afternoon away from getting that to work. But let's see. Okay, so I've renamed this function List Foundation Models.
Okay.
So now
And
the
of course, the
question
function could be looking way better because we're hard coding a lot of things there, right? So you could have a generic function that does a thing and then just pass it what you want it to do in the path and the Drachma host.
there we go. Well, now the question is,
We can't see it, by the way, if you're
Oh,
trying to show something.
let's see. So now putting this back on screen, the next step is going to be taking this, and it's going to be returning a JSON object.
Okay. Yes.
I think that is a question for another day.
That absolutely.
But Darko,
Look,
thank you for the
I like it.
struggle.
I like it. This was very fun and it was satisfying. We managed to get a JSON object back. What every growing developer needs.
I guess this is neat that it really this signature process is intricate. But this is the cool thing, right? Is we will never have to solve this again. It's done.
But no, that's actually good. Like once you figure it out once, because again, what we learned today is that the signing of a request requires very particular information, and you should kind of know what the other side expects, right? Because the other side, the API endpoint, saying like, you know what, you are sending us this data, we're sending like the object and everything, and like based on this, based on your keys, because we know your keys or we know the signature of your keys, whatever, we know what the signature should be. And then if you don't send us the exact same signature, there's something's wrong. So that's pretty good.
Well, I think in our respective roles as developer advocate and community builder, I want to put a blog post together with this so that
Let's do it.
future Googlers,
Future generations of future generations of Lisp developers can absolutely list better. But I think next time we do this thing, we should definitely just make a call. We can do posts now. We can post stuff, Stephen.
This is good. So I think coming up soon will be using BedRock. Now we're talking to BedRock in Lisp, a 60-year-old language talking to a 6-month-old service.
Oh my God, that's amazing.
That's cool.
Amazing. That is amazing. Stephen, thank you so much. Folks in the chat, thank you as well. Hope to see you soon.
Yeah, have a good weekend.
Bye.
Bye-bye. Talk to you later.